Alright, hey everyone. So this video is going to talk about more of the conceptual side of some of the calc problems that we've been doing so far, or at least some of the topics that we've been doing. This one is going to go over the limits, the first derivatives, and the second derivative. But essentially, we're going to start with limits, go over some of the basic information, and then talk about a more logical approach to it so that it might be easier to understand. So limits basically describe where the function's going. It'll look like this. So limit as some x value goes to a number. So c is going to be a constant in this case. Then you're going to have a function, and then you're going to have the value that you find. This is essentially spoken as the limit as x approaches c is L. So that it really means as the value of x in this function gets closer to c from either side, so it's coming across the function like this, the value of the function gets closer to L. So if I'm saying the value of x is getting closer to c, the y value of that function is getting closer to L. So sometimes this calculation is as easy as plugging in that value that you're looking for into the function that you're given. And that'll spit out a value of y, and that's the way to go. But sometimes it gets a little bit more complicated in that the function won't, or the limit won't exist. And as you get into more complicated limit problems, that'll become the case a little bit more commonly. So the way to tell if the normal limit, which is this limit, exists is by using one-sided limits. So obviously if I'm walking, or if I'm driving down the road, right, and I'm driving to Publix, I'm driving north down the street, Publix is going to be on the right, right? If I'm driving south down the street and Publix is not there, then obviously that's a little iffy. So it's that same kind of concept. So if the function is approaching something from the right, so from the positive values, which is why there's a little plus there, so it's limit as x approaches c plus is essentially going to be coming from this side. So that's said as the limit as x approaches from the right. C minus means it's approaching it from the left. So the negative, the lower side of those values. So essentially the reason you find both of these is because if those numbers are the same at the end, so the L values are the same at the end, the limit does exist. Because if Publix is there, no matter where you drive down the road from, obviously Publix exists. If it's not the same number, that limit does not exist. Okay? So obviously if I'm driving down the road and Publix is not there one time and it is there the other, it doesn't exist. So then there's another thing called limits of infinity, or infinite limits, and limits at infinity. So infinite limits talk about where the function goes to infinity. So it'll either shoot up or it'll shoot down. And think about that actually as a vertical asymptote. So it's going to go higher and higher and higher and higher, and then it's not going to pass a certain threshold, but that'll be a vertical line that describes that threshold. A limit at infinity is the end behavior of the graph. So if I travel as far as I can down the x-axis one way, and it gets closer and closer and closer to one value, that's a limit at infinity, and the limit will be that value. Same thing the other way. So if it's getting closer and closer and closer to the x-axis, the limit negative infinity is 0. And then again, those will be described as a horizontal asymptote. So it's the same threshold, but this time it's horizontal. So one of the applications of limits is continuity. So if you think about what continuous means to you, it means it's unending, it's nonstop, it won't break, essentially. So a function can only be continuous. This is the kind of mathy definition of it. A function can only be continuous if at any point where x is equal to a, so a is just a random number, so if x equals 4, the limit of that function must be equal to the value of that function at point a. So basically, what I'm saying is if I say the limit as x approaches 4 of this function, right, it has to be equal to if I plug 4 into that function. So if x is approaching 4, if I'm looking at it this way, if x is approaching 4 from both sides, right, and it gets closer to, let's say, 7, but if I plug in 4 into that function and it's actually 16, that's not continuous. So we'll talk about that a little bit in another video where I go over a couple problems, but it's kind of logical. So if you're expecting a value to be somewhere based on where it is around it, but it's not there, it's somewhere else, then it's not continuous. So all of this is good, and talking about like some of the exceptions and whatever is a little bit helpful in terms of understanding it a different way, but you're not going to be able to do these problems unless you find the unless you know how to find limits graphically, you know how to compute them, and you know how to interpret the properties of limits. So all of this will be stuff that you went over in class. And there's going to be rules and procedures and actual stuff on how to do it. But if you don't know this and you only know all this stuff, you're not going to do very well. So I would know both if I were you. So that's all for limits.